Welcome back. In this video, we're going to use Gauss-Jordan elimination to solve a system of linear equations. So essentially a continuation of our last video. So we have our system of equations here. X sub 1 minus 2x sub 2 plus x sub 3 equals -4. You can see we've got our system. And we'll write this in matrix form. A times x equals b, where b is our constant row. We've kind of pulled out our x1, x2, and x3 and got our coefficients here. So our augmented matrix does look something like this one here, which I'll just refer to as m sub 0. So our coefficients and our constants, and we've got all that. What we need to do is we need to do our Gauss-Jordan elimination and get it to this particular matrix. So the book is not real helpful. They just say use Gauss-Jordan elimination to get it to that point. Well, the hard part is doing all those row operations to get it in that position. So most of this video I'm going to be presenting here will be showing you how to get this into reduced row echelon form. How we're going to start here is we need to get this into reduced row echelon form. So what I want to do here is I want to try and make some headway here on our third row, as I'm going to take -2 times row 1 and add it to row 3. And what that is going to do here is that's going to take this 2 here and make that a 0. Let's take a look at what that looks like. -2 times row 1 is, that becomes -2, +4, -2, and +8. And we add it to row 3, which was 2, 3, -2, 2. Our new row 3 becomes 0, 7, -4, and 10. So I'm just going to rewrite this matrix again. And now our new third row, 0, 7, -4, and 10. So I've got this matrix here. I'm going to call this matrix sub 1. Now I'm going to go to work. Again, I'm going to keep working on row 3 here. I'd love to get this 7 to become 1. So now I'm going to multiply this row 2 or row 2 by -7 and add it to row 3. So -7 times this particular row. So this becomes -7, this becomes -14, this becomes -28. We add these together. I'm going to get a new matrix. I'll go ahead and recopy that down. -2, 1, -4. My first row stays the same. My second row stays the same. And my third row, once I add these together, my third row becomes 0, 0, -18, -18. I will call this M2. That was a result of multiplying row 2 by -7 and adding it to row 3. I can go ahead and take -1/18 of this row, so this just becomes 1 and this becomes 1. So now these are 1s. So now we're in good shape here on row 3. So now what we're going to do is we need to try and eliminate. So now I'm going to do -2 times R3 and add it to R2. Recopying, our top row stays 0, -2, 1, -4. But our middle row, so I have -2 plus 2, that becomes 0, and -2 and 4, that becomes +2, and that stays a 1. Got a 0 here, and then our third row is still 1s. So now I have a new third matrix. We're looking pretty good here. I've got 0s and 1s, but now I need to go to work on the top row. I am going to multiply row 2 times 2 and add it to row 1. So 2 times row 2 plus row 1. So if I multiply all that by 2, this becomes 2. This becomes 4. So now my new top row becomes 1, 0, 1, 0. My second row stays the same. My third row is my 2 1s. So that's my fourth matrix. I've done some rewriting. I'm making some good progress. I just need to eliminate the 1 in the top row. If I take the opposite of row 3 and add it to row 1, my new row 1 becomes 1, 0, 0, negative 1. My row 2 stays the same, 0, 1, 0, 2. My row 3 becomes 0, 0, 1, 1. Finally, my fifth matrix is in reduced row echelon form. And then we can see here that x sub 1 equals negative 1, x sub 2 is equal to 2, and x sub 3, which we've known for a while, is equal to 1. And that is the final solution to that system. And you'll get some more practice with using Gauss-Jordan elimination to solve systems of equations when I see you in class.